Swayam Prabha. Digital India. Educated India.
Characteristic feature of that process. So another from your table, whatever you discussed. Okay.
Phosphorescence is time associated to both.
Okay, so another way of looking at it, there should be some difference, right? So one of the ways you can make the difference is, anyway there are so many energy levels. So fluorescence may be from one type of energy level, phosphorescence can be from another energy level. That is true also. Okay, but let us try to understand more and more and then see how we can finally define fluorescence and phosphorescence. What did you discuss?
So what they said, in addition to that, when you're shining like some kind of electromagnetic radiation, you get an energy excitation of electron and it goes to an excited state.
Right.
So depending on how long that electron can stay in that excited state before coming down, it's either going to be fluorescence or phosphorescence. We discussed that if it goes to a very high energy level, then it's going to come down quicker. That will make it fluorescence, like almost instantly. And if it goes to like a lower energy level, it can stay there for quite so sometimes like nanoseconds or microseconds, and that will be phosphorescence.
This is another way of trying to say that why phosphorescence is a slow process. So suppose it goes to an energy level where it is not stable, it has to come back quickly. So that it comes back and give out energy, that we say fluorescence. But somewhere an energy state, it provides more stability. What he says is that because it may be a lower energy that we provide stability, that is another way of looking at it, so that it stays more time there, so slowly it comes back. So that is phosphorescence. Okay, let us see what this table comes out.
Phosphorescence does based on the electron gets
So now this team is bringing up another concept called spin of the electron. Here they are all talking about energy terms. Here you are bringing another concept called spin of an electron, which is also an important thing. Spin in the ground state, spin in the excited state. Can there be difference in the spin? Only two possibilities, up spin, down spin. But is it changing, and is that affecting the slow process? I mean the slowness of process. That is another way of looking at it. Anything, any additional aspects? Okay. Okay. Okay, because of the spin flip, so you are saying you have the combination, that means energy is also getting affected. Energy is not affected. Okay. After excitation, there is a spin flip happening to the electron. That's what you are saying. My question is, okay, spin flip happen, whether that affects the energy or not. Spin flip requires energy, and because of that energy taken from the system, the energy of the whole system goes down. Then it should come back quickly, or it should. Why it is slow process? Because one more flip is needed. Why one more flip is needed? So you are starting with an assumption there are two electrons in the ground state. Right. That is assumption, right? So in the beginning, okay, let us hear more viewpoints. What do you come up with? The difference between fluorescence and
when electron excites to a certain state, it has two ways of coming down.
Okay.
So one is directly to the ground state.
Okay.
Or otherwise with the intermediate state it can come back.
So what is this intermediate state?
Lower energy.
So that is what something that common to what they said, right? Goes to a lower energy and come back. Okay. What do you come up with? Whatever they said, there is no additional points. Okay. Any additional points from your team?
So we had a lecture on which we discussed phosphorescence.
You had already a lecture.
Yeah, no,
Very good.
we didn't go into phosphorescence in the depth. It was like a short, phosphorescence was like a side topic of that.
Okay.
So he kind of explained the spin flips to us, and he called it like singlet or triplet states. I don't exactly remember.
Okay.
But that is our viewpoint, the spin flip thing.
Right. So why did he mention why it is called singlet, why it is called triplet?
Yeah, I remember, but I left.
Okay. Don't worry. Your team? Your team first. Yeah.
And so that it goes up, and what happens in fluorescence is that it directly comes down. But in phosphorescence, since it involves a spin flip, it has to get reversed and come back. So there is another triplet state, and it needs to spend some energy. So it goes to the triplet state and then comes back. So it takes more time. So phosphorescence also takes more time.
So there is energy concept, there is spin concept getting involved in this whole process of differentiating fluorescence and phosphorescence. Same thing, whatever others said. Okay. So let us try to understand the same thing whatever the professor told, but from a slightly different point of view, in the sense there are energy levels, different types of energy levels. Now when light, that means photon, which is a wave packet which contains both fluctuating electric and magnetic fields. It is falling on matter. Matter contains electrons. The first thing that interact with the photon is electron, that is outer shell, right? So the electron also have electric field and magnetic field. So these fields can interact. The incoming species also has a field. Here existing species also has a field. So fields can interact. So there can be electric field interaction, magnetic field interaction. Because of these electric fields interactions, out of these two things, electric field interaction is stronger than magnetic field interaction. So these transitions are electric dipoles. Okay. And there are certain cases magnetic fields also drive, but that's a special case. So when electric field interacts with each other, what happens is, it's like a wave. So there is this polarity change. The electrons start oscillating. That means the induced oscillation of electron cloud as a result of this wave passing through the medium. Wave is up and down. So the light induces a polarity difference in the electron cloud. Now the frequency of this oscillation of electron cloud and the frequency of the incoming light wave resonate. In that moment, energy exchange is possible. Only at that condition, energy is exchanged. Induced oscillation will happen whenever light falls on the matter because it's electric field interaction. But absorption will not happen. Absorption happens only when resonance condition is met. That is, the frequency of the incoming wave and the oscillation frequency of the electron cloud matches. Then energy of this wave can be absorbed by this matter. Okay. Once that happens, so for example, in the outermost orbital, there are 2 electrons, for example. Suppose it's an s orbital. How many electrons you can put in s orbital? 2 electrons. So when this light wave comes and this interaction happens and resonance condition met, the photon energy is absorbed. 1 photon energy is absorbed usually by 1 electron. Okay, there are exceptional cases, but suppose that is happening, then the system is excited electronically to the next excited state, but there will be an orbital separation for the electrons. S orbital, electron will go to the p orbital. Electron jumps to the next level. So orbitally, these electrons get separated in the first excited state. Ground state, they are in the same orbital. But after the absorption of the energy, they cannot stay in the same orbital. It has to go to another orbital. So there is an orbital separation in the first excited stage. Now you look at this guy, because it's having higher energy and it is not paired, there is a chance for spin flip. It can flip the spin. Poly will not object. Poly will only say that as long as they are together, they cannot have same kind of spin. But if they are alone, that is their choice. So, as a result, there can be another configuration like this. Suppose the flip of the other one changes. This state is called singlet as long as they are paired, all are singlet. This is S0, this is S1. 0 means ground state, 1 is excited state. But spin state is called singlet because there is only one spin state possible. Total spin is calculated by 2s plus 1. If you calculate that, the value will be 1 for these states because of the pairing. But there are 3 ways of arranging the spin states if the pairs are parallel. That's why this is called triplet. Now, why triplet energy is less than that of singlet energy? That means it goes to singlet, then there is a spin change happens, it goes to another level. Now it can come back. It can come back by another flip change, then only it can come back to this stage. So because of this spin flip process happens, this phenomena is called phosphorescence and that takes more time. Whereas suppose it emits from here without undergoing spin flip, it is called fluorescence. In other words, fluorescence is an electronic transition between the states of same multiplicity, same spin multiplicity. This is same spin multiplicity, singlet. This is triplet. So if the transition is between states of different spin multiplicity, you say it phosphorescence. If it is same spin multiplicity, it is called fluorescence. So that is why a photophysical student defined fluorescence and phosphorescence. Electronic transitions between the states of same spin multiplicity, you define it as fluorescence. Electronic transition between states of different spin multiplicity, you call it phosphorescence. Okay, now the question is why this energy is less than this? Some people say it takes energy to flip the spin. Energy is required, but that is not the sole reason why this energy is less than this. There is something called exchange energy that you heard about, right? Exchange energy. So that means as long as the electrons are orbitally separated, they can interchange. Now, this interchange phenomena happens, this electrons cloud has to spatially come close. When it spatially come close, in which case you think they can come close, more close? This case they can come closer. Both are electrons, both have negative charge, like charge, repel each other. So the repulsive energy between these two things will be high in the case of singlet, low in the case of triplet. So that is another major reason why triplet state is having lower energy than singlet state. There is an exchange energy which is favoring the triplet state, whereas it is hindering in the case of singlet. That is another aspect. But in any case, this have a lower energy, it comes back slowly because there is a spin flip involved. So let us quickly say the time scales involved in these processes. Have any idea about how quick absorption happens? Femtosecond. What is femtosecond? 10 to the power of minus 15 second, right? Fluorescence time scale. Fluorescence time scale. Fluorescence is in nanoseconds. Phosphorescence time scale. Minus 6 is possible, minus 3 is possible, sometimes it takes seconds. You see those when you are kids, they put all those moon stars on the walls. that phosphorescence, right? So that takes seconds. So phosphorescence is a broad range. It can be from milliseconds to seconds. It comes in many in a range. So this is the reason why. But fluorescence, phosphorescence is only two major process of light matter interaction, but there are many other things. And then we can actually, using these phenomena, we can think of making large number of applications. So in research field, people use this fluorescence, phosphorescence, all these phenomena, light matter interaction for practical use. For example, we have 2-3 minutes. One, can you think of some applications based? This is a phenomena. You're all young scientists. I give you this phenomena. Can you come up with some way of using this for common man's helping somebody? Okay, yeah, think about something. How do we use it? Okay. I see. Okay.
Add a phosphorus material to a drug and give it to a patient and see which parts of the body accept it and that's absorbed.
A lot of biomedical applications are based on this light emitting species. You can actually inject something in the body and track because of this emitting things. Yes. Emergency? Okay, emergency lights, right? Yeah, so that will, even if in the absence of a power for a few seconds, it can show you the emergency light. Yes. Extend the light. Yes.
High visibility vests. If you're working in like a dangerous area and you want to make sure that you're able to see the people, you have like a high visibility vest.
Okay.
Light comes, it will shine brightly.
So is it fluorescence or?
It will be phosphorescence.
So then it becomes more visible. That's what I'm saying. Okay. Anything else? A lot of studies are there to use for sensing purpose. For example, toxic species are there in your system or not. Depends upon the absence and presence, this light emitting process will change. This your probe, your molecule which is absorbing the light can bind with a specific toxic material. As a result, your emission can be wiped out. So that area is called sensing. A lot of research work is going on there, so that you add your material into a system. If it is not emitting, that means that specific toxic element is there. So there's a very specific binding process between a molecule and an analyte that can kill the emission process. Hence, you can detect that. So like that, a large number of phenomena are there which can use for applications to help human beings. So that's why people study the study the basic elements of light matter interaction and try to see what best we can do for society, human being, etc., etc. Okay. Any quick questions? Yeah.
How does reflection work on like an atomic scale?
Reflection. Light reflects. See, one way of understanding reflection is light falls on this any material, and then every material, for example, is a crystal, right? So crystal has lattices. So this lattice, that means electronic display. The electrons are in this specific array. It is coming. So light comes and the energy gap is not helping them to absorb it. The gap is not. This is the condition for absorption. So that is not happening. So another way of is light has to travel straight and there's an object and it basically doesn't allow to absorb. The only possibility is divert its path. Either it has to go through the medium. Suppose the medium is not allowing to get through, that's degree of opacity. Then it has to reflect. There is no other possible. Either ways, diffraction is another possibility. It can go through, divert the path and then go. That is diffraction, we say. So reflection is something where there is a degree of opacity is playing the major role there, which doesn't allow it goes through the material.
So why doesn't it get converted into like rotational energy or translational energy?
For everything that condition has to match. That means any energy that you're talking about, this whatever gap that energy levels involved, your light photon has to have the exact energy. Then only it will get used for that. Otherwise, there is no interaction, there is no exchange.
What is the fundamental property of materials which gives them the degree of opacity?
Fundamental property that gives the material for opacity. Opacity, transparency, these things are essentially, it could be the electron distribution, electronic distribution, that probably is the one that facilitating the travel of photons or blocking of photons. Yeah, so basically that's what I'm seeing electrons as the a kind of a shield for the in the path. So there can be interaction, those interactions can be directing the photons away. Possible. That is one way of understanding it. Yes. Good. You have a break now for tea or something? You are getting tea, coffee, snacks. Life is beautiful. Good. Thank you. Thank you very much for this brief interaction. Hoping to see you around for a few more days. I think next week you are winding up, right? Okay. So keep in touch with all of us. I didn't get time to interact with you for asking you what do you want to do, what are your ambitions. So many questions I have, but there is no time. Yeah, we need to stick to the time. Yeah, you can do your job. Yes.